Welcome back everyone to another episode of the Doom Remake series, and in this video we are gonna get started with loading WAD files. So I'm going to open up two new files in our project directory. One is wad.h and the other is wad.c, and in here we are gonna add of course the mandatory include guard, and after that let's create a struct called wad, and this will represent all of the data related to a wad file. And we'll currently leave this struct empty, but we'll have a function that will return an int depending on the error status, and it will be called wad load from file. It will of course take the actual file name along with the pointer to the wad in which to load this. And I'm gonna copy this from here, go under wad.c. In here let's just include the wad.h and create an implementation of this function. If everything succeeds, we are gonna return 0 at the end, much like how standard error codes work, and we are gonna include stdio.h here so that we can access the file system. So we are going to open up the file name, and we are going to open it up in read binary mode, and if it's null, which means it failed to open up, then we are going to return with an error code of 1. In the end, we are just going to close this file. And it might also be useful to make sure that the WAD pointer that we actually get, we are supposed to write to, it's not null. Yeah, we are gonna, if it's null, we are gonna return with an error code, and we are gonna return with a different error code if the file fails to open. Now we load our whole file into a buffer by getting this, by moving to the end of the file, getting the size, and then loading it into a buffer of appropriate size. And the reason we do that is because first of all, it will allow us easier random access. We can access any point in the buffer that we want without having to use fseek or anything. And secondly, it would make it much easier to deal with different byte encoding. So the WAD files are always little endian, but the processor might be big endian, in which case it can cause some problems. So we just load it into a buffer like this, and in the end we free that buffer because all of the data we need is gonna be stored in appropriate structures, and between these lines we are supposed to read the actual data. So we first need to read the header of the WAD file. It consists of 12 bytes. The first 4 are the ASCII characters IWAD or PWAD, and then we have got the number of lumps in the WAD, and we have also got a table offset containing the location of the directory. Now these last two fields, we'll talk about them in more detail in a second. As far as the first field is concerned, that's just the type of the WAD. If it's an IWAD, it means it's a complete game, or if it's a PWAD, it means it is just a patch WAD. Okay, so to give ourselves a bit more freedom, we are going to use a character pointer for the actual ID instead of having a hard-coded array. And for reading the header, we are first of all going to make sure that the size of the file is not less than 12, which is the actual header size. If it's less than 12, we are going to return with error code of 3, which means a malformed WAD file. And we are going to allocate 5 bytes for our WAD ID because, 4 bytes are for the actual ID and then the null terminator. And then we'll use memcopy to copy the first 4 bytes of this buffer into the WAD ID here, and then we're going to set the last byte to 0 because it's going to be the null terminator. And it seems to give an error because it seems like it included the C++ version. So let's see if it now includes the correct one. No, it seems to be including the C++ version. Let's just change it to string.h, and yeah, that should work. Now, since we are managing memory ourselves, we are going to create a WAD free function to prevent any memory leak. So we will create a WAD free function which will take a WAD pointer and it will free all of the data from it. So in here we'll create an implementation of that, and currently of course we are only allocating memory for the ID, so we'll just free it, and later on as we add more stuff we're going to add the freeing code for that as well to ensure proper cleanup. So to test the code we have written, I'm going to open up main.c, and in here I have already got the doom1.wad file here. So we're going to create a WAD here which we're going to just load from with the doom1.wad file, and I'm using the share version. You can use the full version if you want to, and here we'll just print the error code. We'll print an error like if it fails, and then we'll exit our program if the WAD file does not load. And if it does load, then we are going to print a small message just telling the type of the WAD file, the actual ID variable. And if I run this right now, you can see that it says that loaded a WAD file of type IWAD, which is indeed what our WAD file is. Now we are gonna go under wad.h, and we are gonna create 2 unsigned integers here. And do note that the original Doom source code has it as signed integers, but it makes more sense to use unsigned, and their value is never negative anyway, so we can read them safely as unsigned integers as well. So we are gonna create the num lumps and directory offset fields inside of our wad.h. And in order to read this from the buffer, we will define a macro which will allow reading a 4-byte integer from any buffer basically, and this macro will take 2 arguments, the buffer actually which we are reading from and an offset. So now we'll just read the buffer stuff quite easily, and we'll read it in little endian order. So for each byte, we'll read first of all the lowest significant byte, then the other one we're going to shift it left by 8 bits, and then the next one we're going to do it similarly. So basically it's going to be pretty easy to understand. We're just doing a bunch of cool bitwise operations and getting our file that way. And one problem though is that I forgot to actually change the offset. So the first byte is going to be at offset plus 1, offset plus 0, which means just the offset, then plus 1, plus 2, and plus 3. Now in order to read this, we are going to just say WAD, and you can see we have got like our numlums here, and we can just set it to read I32. The buffer is going to be the same, but for the offset I'm going to say 4 here. And now we are going to read the directory offset, which will be of course in our buffer, but the offset will be now 8. So let's go under main.c and let's try to print this information as well. So we'll say with this amount of lumps, and we'll use u here actually because it's unsigned, and then we'll say with directory at whatever the directory offset is. We'll specify these values here. So in order to test this out, I'm gonna go ahead and run this, and what you should see is that it says loaded a WAD file of type iWAD with 1264 lumps and directory at whatever this is. And if you were to actually test this out, this is indeed the correct data. So yeah, that's pretty cool. So now we are going to read the directory, which consists information about all of the different lumps. So this is the basic structure of the directory, and now we are going to get started with reading this. Okay, so in order to do that, I'm gonna go here and we're gonna create a new struct here for representing each lump in the directory. And now let's go ahead and add a couple of different variables in there. First of all, one for offset and one for size. And I'm also going to create a character pointer here for the actual name of the lump. Now in here we'll just have an array of lumps pointer because dynamic arrays, we don't know the size at compile time. And we'll go over each of those lumps, and in here first of all we'll calculate the offset of this current directory, which you can calculate quite easily by getting the total offset of the directory multiplied by I plus I multiplied by 16, which is the size of each directory. We'll allocate appropriate memory for our lumps, and with that done, now we can go down here and get started with actually reading this. Alright, so with that offset calculated, we are going to read this like this. So we are going to first of all read the offset of the actual lump, which is the first entry as a 32-bit integer, and then the size, which is read for the next 4 bytes with also as a 32-bit integer. And for the name, it can be maximum 8 bytes, and it may not be null terminated. So we are going to allocate 9 bytes of memory for the name, and then we are going to copy that appropriately. So we are going to copy the buffer, and of course we are going to use offset plus 8 as the actual where we want to read from, and we are going to copy 8 bytes from there. And if it's less than 8, it will be null terminated. And now we are gonna just set our name's last value to be 0 as the actual null terminator in case it's not there. And then inside of the main file, we are gonna just print all of the lumps here to test stuff out. So I'm gonna just go ahead and print those. First of all, the name of the lump, followed by the actual data of the lump, the size and the offset. So we are going to put the offset here and the size as well. And then if I go ahead and run this, what you should see is that well, we got a lot of stuff here, and actually that's a bit of a mistake. I forgot to put a new line after this. So we're going to put a new line, and then we're going to run again, and now you can see that we get all of our lumps here. And if you were to open it up in an editor like Slate, you will find out that we are getting all of the lumps read correctly, which means that this is basically working. And now we can get started with the actually reading the lump data. So for that, we are going to create a unsigned integer buffer here, similar to the one we have got here for actually storing the lumps data. And for that, we are going to allocate some bytes for it, and the size of that is going to be equal to the size of this lump. So we're just going to say WAD lumps I dot size, and then we are going to use memcopy to actually copy into this data our buffer size, but we are going to use the lump offset for the actual position, and for the size we'll just use the lump size. And that should copy all of the data here correctly, and that is gonna be all we need to test this. And if I run this, we get no segmentation faults, which means that this code is working. Anyways guys, this is pretty much it for this video, and I'll see you in the next one, in which we'll get started with actually taking some of this lump data and loading it into some appropriate structures so that we can visualize our map first in 2D, and after that we'll move on to a 3D representation. So yeah guys, stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one, and bye.